All right, this is the triangle angle sum theorem. I'm abbreviating things. And this is an important thing in geometry. And it has one of the coolest proofs, one of my favorite proofs in all of geometry. And we're actually going to go through our first kind of proof today together. I'm not going to write it out in great detail like we will in the second semester, but I want to go over it with you because it's neat.
No matter what triangle, isosceles, equilateral, or all inside angles add up to 180.
That is the theorem. Thank you for that. Let's go ahead and draw a triangle. Now, do your best to make the bottom of the triangle flat. We'll see why this is important in just a moment. Draw yourself a triangle. My line goes out a little bit further on both sides, but that's okay. It's not a big deal. And label the angles. I'm going to call them A, B, and C. Yeah, the angle sum theorem means that we're going to add those up. So the measure of angle A plus the measure of angle B plus the measure of angle C for any triangle, parentheses, that's drawn on a flat surface, in parentheses, is equal to 180 degrees. So those of you who go on to higher level math, you take a college level geometry course, you'll study a couple different types of geometry. We do planar geometry in high school, which means everything is drawn on a plane, 2 dimensions on a plane. You can also do 2-dimensional on a sphere though. So instead of drawing on a piece of paper, we draw on the surface of a globe. And there's a thing called a hyperbola. Hyperbola kind of resembles a saddle, kind of curves this way, but also curves down going this way, but up going this way. And hyperbolic and spherical geometry have different rules about what the angles add up to. It's not always equal to 180. Spoiler alert, in one of them, it always adds up to something less than 180. The other one, it always adds up to something greater than 180. But for our purposes, in this class, we're going to assume that any triangle that we see is drawn on a plane on a flat piece of paper, and that it adds up to 180. So I'm going to show you the proof of this because I think this is really cool. Somebody very clever came up with this proof. And it relies on something that we already know. So if you don't have your packets out, it might be a good idea right now to have them out and flip to that second page. Folks, my assumption right now is that if I show you a picture with a bunch of angles in it, you can find me vertical angles, and you can find me straight angles, and you can find corresponding and alternate interior and same side interior angles. And if that's not the case, that's something you need to practice with, which we will, obviously, in the homework, and we'll do some practice together here later in the period too. So what other types of angles do we know that have something to do with 180 degrees from that page? Corresponding angles add up to 180. Straight angles. So any part of a straight angle, those would add up to 180. What else? Supplementary angles add up to 180. And what types of angles are supplementary from that sheet? Same side interior angles are supplementary, but only if the lines are parallel. We don't have any parallel lines in this picture. All right, so, and then the other types of angles that were congruent were, what are congruent? What pairs are congruent? Vertical angles are congruent always, or only when lines are parallel? Always, vertical angles are always congruent. And then corresponding angles are congruent only if lines are parallel. And alternate interior angles are congruent only if lines are parallel. So keep all that stuff in mind. So here's the clever trick that someone figured out. I think this is awesome. See if you can follow along with me here. They said, okay, you got the bottom of your triangle here. I'm going to draw a line through this point at the top of the triangle. And I'm going to make sure that when I draw that line, it's parallel to the bottom. So whoever came up with this proof added an extra line into the picture. And by doing this, they created two new angles. You see the two new angles that are formed here? And I'm going to call it angle E, or angle D and angle E. Now, because that line is parallel, we should be able to use one of those five things in our package. What are you now seeing? What angle pairs are you now seeing from our package? What do you see? Vertical angle? I don't see any vertical angles. D and E kind of look like they are, but they're not totally across from each other. Corresponding angles, I don't see any corresponding angles either. I do see a pair of alternate interior angles. Which two angles are you looking at? Give me one of them, just one of them. A and C are not alternate interior angles. Yeah. A and D are alternate interior angles. And I marked them congruent. Should I have marked them congruent? Our alternate interior angles are congruent? Is that true? Only if what? If the lines are parallel. Well, the lines are parallel. We made sure of that when we drew the line. So that's good. So A and B are the same because they are alternate interior angles. There's another pair of angles on this picture that are also congruent. It's the other one. C and E are also congruent because they are what? They are also alternate interior angles, which are congruent only if the lines are parallel. Right? How does that help us to prove that the angles of the triangle add up to 180? What can you tell me about these three angles up at the top here? Those three angles would add up to 180, wouldn't they? They would add up to 180 because they're forming a straight angle, right? So I know for a fact that the measure of angle D plus the measure of angle B plus the measure of angle E equal 180 because they come together to create a straight angle. It's not technically a straight angle pair because there's three of them. Pair implies two. Can you put your phone away, please?
Straight angle trio.
Straight angle trio, I like it. So where's the leap of logic from here to here? Well, you just told me that A and D were the same, right? And that C and E were the same. So then that first equation's got to be true also. So somebody very clever decided, let's draw that extra line in. And if I could just transfer A up to D because they're alternate interior angles because of the parallel lines, and if I could transfer C up to E, then it becomes very clear that those three angles are going to add up to 180 because they're making a straight line. And that's the proof for this. You get that? Isn't that cool? I think that's really cool. I think that's very clever. First of all, somebody had to think like, I want to draw an extra line in there, which is, yeah. We do that from time to time in proofs. All right. So we know that angles in a triangle add up to 180. We're going to use that now for a couple examples. And I asked you to get your books, so we might as well open them up. Let's look at page 99. And we're going to do problem 38 together. And for part A, it includes a figure, and we need to draw figures when we see them in our book here. So let's go ahead and do that. Now, I'm going to guess that some of you might not feel the need to write an equation for this first problem, but I'm going to encourage you to do so anyways. We're talking about, when I see this information, I look at this picture, I see three angles in a triangle, and that immediately makes me think of an equation that looks like this. Remember we talked about our different styles of equations? Angles inside of a triangle add up to a particular number. So that makes you think of an equation that's got three things, because there's three angles in a triangle, adding up to something. And what is it that they always add up to, as long as we're writing them on a flat piece of paper? Awesome. So can you fill in the other pieces of that equation and go ahead and solve it for me, please? And do your combining like terms and get x by itself. Let's figure out what x ends up being. We come up with 60. You could leave them separate, but then instead of one step to get rid of 120, you're going to have to do two separate steps to get rid of the 80 and the 40. So I recommend when you're solving equations to always do those three things that I taught you. Take care of parentheses first, combine like terms, deal with x's on both sides. If you do those three things, you're going to end up with less work overall, a more efficient solution. You don't have to, though. If you forget to do them, you can still come up with the right answer. It just may take you a few steps longer. Personally, I'm trying to do as few steps as possible for a couple different reasons. One, I got other stuff to do. Right? I'm sure you do too, right? Things that you have to do, things you want to do, right? But two, every step that I add in is one more opportunity for me to make mistakes, and I make mistakes a lot, right? So if I can reduce the number of steps, then I can reduce the number of places that I might possibly make an error. Yes. Good. Yeah. So you looked at this and you said, "Oh, I got two angles that must add up to 100, right? Because I'm using up 80 right here." So here's a good mental math for you. If I'm using up 80, then these other two have to add up to 100, right? Because they have to add up to 180 altogether. All right. Well, 40 and 60. It's got to be 60. So again, like I said when we started this, many of you will probably have some ways other than writing the equation you can figure this out. But I want you to get in the habit of writing an equation because, like in part B, sometimes it's not so easy to do it mentally. So go ahead and, if you haven't already, go ahead and sketch part B. This one gets a little trickier because we have x's in multiple spots. So again, see if you can write me an equation. As soon as I see a triangle and angles inside, I'm thinking we should have some stuff adding up to 180. Let's fill in what those angles are. Now we've got an equation we can use to solve for it. case, I would definitely recommend combining like terms first, because you got a couple of them to do. Or if you could get away without doing them, you could get away without combining like terms in this one, but this one's gonna cause you a lot more work if you don't, right? 2x and 1x, 3x, 16 and 96 is 108. And then a couple more steps of algebra to get x by itself. I don't think so. I think 72 divides by 3. Yeah, I think it's like 3 days is 72 hours. So 24. When I see 72, I always think of 72 hours is the same as 3 days. You guys are 48 hours is 2 days, 72 hours is 3 days. So 72 divided by 3 is 24. Now, are we okay on that so far? Now remember, one of the great things about geometry is that whenever you have to solve an equation, there's usually a really easy way to check and see if you did it right. And that's to plug that number that you got back in and figure out what the actual things you were talking about are. In this case, we're talking about angles. So if I were to take 24 and plug it back in here, what am I going to get for this angle? What is 2 times x if x is 24? This would be 48. What would I get here? If x is 24, we get 36. Somebody with a calculator add up 96 and 48 and 36. Does it come out to 180? If it does, then I'm going to feel really good about my algebra. And it does. All right. We're going to do a problem that is not, I'll repeat, not in your book. So look up here. We're going to call it problem 39, but we're going to make it a little bit tougher because you guys can handle it. I believe in you. So let's draw this thing. So it's a triangle. All right, this one's a little bit tricky because if I want to try and solve it the way we've been solving the last couple, we don't have enough information to fill out our equation, do we? I only have 2 of the angles. What do you notice? Yes, good for you. Because why? The 2 sides are congruent, which makes it isosceles. And any middle schooler can tell you that an isosceles triangle has 2 equal sides. What do we learn in high school about isosceles triangles? They also have equal base angles. So this angle and this angle, because they're the ones across from the equal sides, would also have to be congruent. So if I'm calling this one 3x, what could I call this one? This one would also be 3x. Now I got enough information to write an equation. Go ahead and finish writing that equation, solve that for me. And then do what we did just a moment ago. Check and make sure that the equation gives you an answer that works when you plug it back into the actual picture. Use your calculator if you need to. 4 divided by 12 is 12. So 4 divided by half of 12 will be double 12. Who's tricking me on that though? Is it 24? Woo! Mental math. Which would make this. What's 3 times 24 again? I'll make that 72. This one also 72. Does that work? 72 plus 72 plus 36. Does that give us the 180 we're looking for? All right. All right, we got one more problem for you. This one's for the win. And as soon as you finish this one up, you can start on the homework. So I'll get you to copy this down. It's number 40. But let me give you a hint. When you draw number 40, leave all the letters out. Leave the letters out. Draw it and just put the numbers in. Something like that. This figure has, I'm counting 13 different angles in it. 13 smaller angles. Like if we don't combine any together. You see in 13 also? And only 2 of them are marked. Your job here is I'm coming around and stamping homework. I would like you to mark the other 11 triangles. So there's some easy ones. Let's do an easy one. What would this angle have to be right here? 57. Someone convinced me that this angle is 57. Why would it be 57? Because they are vertical angles. Ooh, good. You've got these vocab and these properties down. Those are vertical angles, and vertical angles are congruent. Now I'm going to give you a big hint here. This is not 81. It is not. I would need to extend this line right here, and then this would be 81. But it would have another little piece to it here as well. So don't call that bottom piece 81. Now I need you to use your packet, use your notes. Look for corresponding angles, alternate interior angles, same side interior angles, straight angle pairs, and vertical angles. You're going to find all of these in this picture. And you have parallel lines. You should be able to use the property of those things to fill out the rest of it. Along with the 4th or the 6th thing, rather, that we learned today, which is not in your packet yet, and that is if the angle is inside of a triangle up to 180. I do see a triangle here, so once you find 2 of those angles, you should be able to find the 3rd one. All right, while you're doing that, please have your packets handy along with your homework from Thursday nights. Let me get those stamped for you. Yep. Great. Great. Are you seeing the corresponding angles, the alternate interior angles? Are you seeing those words to yourself in your head when you're working on these? Good. But can you not do that? Finally. me to look at. You need to be able to name them. But please make sure you at least say those names in your head when you're writing them. Corresponding angles, alternate interior angles. I think so. I think so. Do you have the homework assignment? I think so. We're gonna go over in a second. Keep going now. Keep going. No, we only have two. Oh. Okay. Better prepared. What are you on this? Oh, I remember stamping on your actual.
Yeah, got the stamp right here.
Okay, can you get those problem numbers written down?
Yeah.
There we go. Yeah, let me go over this. Let's check our answers real quick. We should be done or close to done. There's lots of ways you can go about this. I would basically, if it were me, I'd focus on this intersection up here at first because we got a straight angle pair right here. Those should add up to 180. 57 plus, I think 123. Does that sound right? 123, and then vertical angles would get me the same thing over there. Did anybody take these two angles and then just slide them down the transversal to these spots down here? What am I doing when I slide an angle down the transversal? Those are corresponding angles. So this would be 57 corresponding with that 57. This would be 123 corresponding with that 123. Did anybody use this 57 and this 57? What would those be? Those are alternate interior angles. Good. All right. I got another pair of alternate interior angles up here. 81 is alternate interior with this angle right here. This would also be 81. These are alternate interior angles right here. And then the vertical angle of that will get me up to here, which is 81. And these two 81s are corresponding angles. And then I could also use this angle right here and this 81. These are, what type of angles are we looking at here? Not vertical. Nope, they're not across from each other. Same side interior. You got this down. I'm impressed. I'm a little bit worried about the rest of the class, but you're doing it. You got it. These are same side interior angles, which if the lines are parallel, they should add up to 180. So I'm thinking 99 plus 81 equals 180. And then I got another 99 here because of vertical angles. What else do I got? I got this 57 I could slide down to here. Corresponding angles, also 57 vertical angles with this 57. And then we got a straight angle pair. We also have a triangle here with the same two angles, right? So either way, either these three angles add up to 180 or these three angles add up to 180. What's that end up being? 43, 42, 42, 42 for that one. All right, let me get you the homework assignment. Again, folks, I need you to be practicing with these names. I think a lot of us know like which two angles are equal, but you don't know that they're corresponding angles yet. So as you're working through this homework assignment, I need you to be saying out loud, or even better, writing down on your paper, what are we seeing? Okay, because you need to be good with the names. I'm going to test you on that. We should maybe do a little quiz here soon. We will do a little quiz on angle pair names next class. I need to stamp a few more of you for homework, so I'm gonna take care of that and I'll answer additional questions. Quick one. Draw the figures, yeah. Please draw the figures. Good enough? Okay. Wait. Oh, did I miss anyone for homework stamp?